Hey, this is Mr. Beckstrom, and today I want to take a look at a problem from section 3.2. This is similar to number 17, and it says using synthetic division. Now let's write down the expression in the form of the quotient plus the remainder over the divisor. This kind of problem helps us identify the oblique asymptote when we are trying to graph certain functions where we have the highest exponent on the top, usually one higher than the highest exponent on the bottom. And the oblique asymptote is just like a horizontal or a vertical asymptote, except it's usually like a diagonal asymptote where the curve is approaching that diagonal asymptote on the graph, usually going towards positive and negative infinity. All right, so let's see how to do that using synthetic division. So what I want to do here is the a minus 3, that's our divisor. So I can use synthetic division since the variable is by itself and I'm adding or subtracting a constant. I can use that synthetic division. Now remember, this is our factor, so when using synthetic division, if I was set that equal to 0, add 3 to both sides, that would give me a is equal to 3. So 3 is the actual value that I use. So in factored form, it's always the opposite of the sign here. All right, so I have 3 as the number, the divisor that I put on the outside for synthetic division, and the values in here are going to be my coefficients up here. Now remember, if I'm missing a coefficient, for example, if I were to go from x cubed to x to the first and I didn't have an x squared value, I'd have to put a 0 for a placeholder there, but that's not the case here. I'm not missing any. So my first coefficient in front of the x squared term is 1. My next coefficient is minus 3, and my last coefficient is 13. So this is how I set up my synthetic division. My divisor on the outside, which is if I'm given it in factored form here or as a factor here, it's always going to be the opposite sign of whatever's there. And then I set it up just like this. All right, so the first thing I do is I bring the first coefficient down like this, and then I multiply my divisor by it. So 3 times 1 is 3. Bring it up here. I add the next coefficient to it. So negative 3 plus positive 3 is 0. Now I multiply my divisor by the new number I got. So 3 times 0 is 0. Then I add my next coefficient to it. So 13 plus 0 is 13. And so this is my this is what I get when I divide that 3 into it. This polynomial here is going to be one less exponent than my original one. So this one started with a squared term, so this will start with an a to the first term. So this one here is actually equivalent to 1a plus 0, kind of a to the 0, right? So I'll kind of say 1a plus 0a to the 0 plus 13 all over the divisor of a minus 3, So this is our divisor right here, the last number. Excuse me, the remainder, not the divisor, the remainder. This is the divisor on the bottom, and this is our quotient. So to clean this up here, our final answer would just be a, because the zero part right here just cancels out, plus, so that'd be our quotient, plus the remainder, which is 13, all over the divisor, which is a minus 3. And this is our final answer there. All right, if you have any questions, let me know. Thanks.